Hello, everyone, and welcome to another edition of The Secure Developer. For those of you, if it's your first time joining us, we are a community that enables to educate and enable developers in application security. So please welcome. I'm joined today by Jamie and Saz, and they're going to be talking about research on the dangers of copy-pasting code. Before we get started, I'm Sam, and a few little housekeeping rules. If you are watching this from YouTube and aren't on our Slack channel, if you head over to thesecuredeveloper.com, you'll find the details to join our Slack. That's actually where you can ask our speakers questions today, so please go ahead and do that. If you're also watching the recorded session after, so not the live session, you can still join the Slack and get your questions in there. And if Jamie or Saz isn't available to answer, we can always make sure that someone is. So please always join us in the Slack. The other thing is obviously that everything is recorded, so all our past sessions are on thesecuredeveloper.com, so please have a look at it. But that's enough from me. Any questions, feedback, ideas on sessions, you can find me on Twitter or on the Slack or on the website. And that's it from me. So I'm going to hand over now to Jamie and Saz, and we're going to get started. Hello and welcome to The Secure Developer.
Hi, Sam. Nice to be here.
Yeah, hi, nice to be here.
So this
Definitely
is
on different time zones, aren't we?
Yeah. If you're just listening to audio, this is the voice of Jamie.
And this is Sazzadur. You can call me Saz.
Perfect. Well, let's kick off. I'll leave it to you two.
Okay. So we are here to talk about the dangers of copy pasting code off of the internet or someone else's code base and into your own code base. Now, you can sort of think in general about all the ways that might go wrong. But we are two PhD students, and our research is on two particular ways that things can go wrong. So my work is about what can happen when you do this with a regular expression or regex.
Yeah, and my work is on like how things can go bad if you copy codes, for example, for specifically cryptographic codes into your code base and how that can go wrong.
So we've both done some empirical work, which means we went out and measured stuff in terms of what real software looks like. So we usually pull things off of GitHub, and you pull things off of GitHub. And
yeah, also from GitHub. And for us, we actually scanned lots of top tier projects from Apache, and we shockingly saw that the story is similar. Mm-hmm. It's similar as someone who are doing things in
everybody's human.
Everybody's
Nobody knows how crypto works. So.
Yeah, and we do understand that developers might lots of the time have different sort of constraints like time. They have limited time, budget, and deadline, and that can also tempt them to copy something directly from internet, but we all know that can go wrong.
Sure. I mean, we're not saying code reuse is bad.
Yeah.
But it would probably be helpful to talk specifically about what can go wrong when you're reusing different kinds of code snippets.
Yeah.
Right? So there's interesting bugs that can emerge when you do this with a regular expression. And there's also some very interesting issues that emerge when you do it with a crypto snippet. We both also looked at Stack Overflow, right? We all know where we get code snippets to reuse. It's by Googling, I need a code snippet for this.
Yeah, that's the thing. So in Stack Overflow, we observed few interesting stuff. So we saw the main problem is most of the time developers actually look for functional codes, not the secure code. So
like I'm a developer and I'm trying to get HTTPS configured on my website.
Yeah, things like that. So somehow you messed up with your configurations, and all of a sudden you see exceptions like bad SSL certificate. Then you do Google search and look for how I can easily fix that thing.
I have an idea. What if I just stop checking for the certificate?
Yeah, that's the way currently it works in Stack Overflow. You will see that answers to the most popular answers to these kind of questions actually suggest to skip these certificate validations or verification.
Really? I mean, how many upvotes are we talking here?
It's like for one answer I saw that that skipping certificates was an accepted answer, and there were 96 upvotes to that.
Lovely.
Yeah.
Well,
so,
I bet it made the code run and stop throwing
yeah,
exceptions.
yeah, that's the thing.
Okay. Well,
And it seems that this is really also loved by the developer community, and that's what the most scary part. Right?
yeah. Well, it's hard once your code is running. I mean, it's the security aspects of it become a little bit invisible. Right?
Yeah.
From a developer's perspective, you're often just saying, is the website working? Can people visit my content? Can people buy my stuff?
Yeah.
And you're not necessarily thinking, is it secure? Because it's running, right?
Yeah, that's the thing. And another interesting aspect we found from our study is like around 96% of the libraries that are being used in Android was kind of offers this kind of bogus code base, like you can skip things easily.
Okay.
One thing that Java follows is open close principle. Like all these classes are open for extension. So interestingly, you can extend a secure class to make it insecure.
Oh.
And most
so there's like workarounds or hacks
exactly
on a lot of these libraries.
Yeah, lot of these libraries also offer this kind of hacks.
Okay.
So that's why developers always have this insecure code at that disposal.
So they've got a streamlined way
exactly
to get their code running but be insecure.
Yeah.
Okay. And if you don't know any better, you copy and paste it, and there you go.
Yeah. For some straightforward insecure codes, what Google does is now they actually screen for straightforward cases that are easily detectable. So now, but there are lots of not so straightforward cases that they can't really detect. So still.
Well, the situation's kind of similar for regexes, actually. I don't know if you know much about regexes, Sazzadur.
Yeah, I think I know.
Well, that's because you sit next to me.
Yeah, I don't have any option not to know.
Yeah, so we've actually, in my research, we've talked to a couple hundred software engineers, both within a single company. We talked to about 100 at a large international media company, and we talked to about 150 developers from all over the place.
I see.
And we asked them, what do you think about regexes? And when you're writing a regex, how do you go about doing that? And they said in conclusion, basically, regexes are really hard and we don't know how to do them. But they also said, and we think that they're really valuable because they're all over the place. There's empirical evidence that something like 30 to 50% of most software projects have a regular expression in them. And why? Because they're a great way to slice and dice strings.
Yeah.
So they're this really convenient tool, but developers say the notation is really hard to read.
Yeah.
There's a joke that there's sort of like a write once, read never kind of thing. And you just, you hope that when there's a bug in your code, it's not the regex, because then you'll have to figure out how the regex works.
So one thing when I was developer, one thing I saw that most of the developer see regex as a magic tool. Like you have a problem, you just want to solve it, and regex is the right way to do that.
Okay.
Because most of the time you don't know what's going on, but magically you give the test cases and it passes.
It passes. It's a miracle.
Yeah, it's a miracle. So that's what one thing I saw. And I saw one interesting question in Stack Overflow, like they want to parse HTML website using regex.
I mean, you could, I guess, use a regex for that.
But the thing is, you cannot do everything using regex.
Oh, you got to be careful with that. Actually, regexes are extraordinarily powerful.
Yeah.
And
having said that, so you cannot just build a language parser using just only regex.
You totally can.
I see.
It can be done, right?
I see.
Certain regular expression engines are sufficiently sophisticated, and they give you a rich enough toolkit that you can actually do wildly expressive parsing with a regular expression, right? They're not the automata theory regexes, if you've ever taken an automata theory class. That's not the regexes we're talking about in production.
I see.
We're talking about wildly expressive things that can do all sorts of mysterious magic, right? That's why it's so hard to
I'm still learning. Yeah.
So you said you work professionally?
Yeah. Around, I think, 3.5 years.
Okay. Is that how you got into crypto?
Well, that's a funny story to share. So when I worked as a professional in payment card industry, and I saw that lots of the time, most of these vulnerabilities and all those stuffs, actually, so you already have the crypto protocols and all those stuff for you at your disposal. But the main problem, the general developers do not really reinvent or implements anything related to crypto. What they do is they actually use those kind of
Sure, we all know you're not supposed to write your own crypto, right?
Yeah. So most of the time we see that even if you don't have enough security background, you can mess up with that too.
Okay.
So for example, we all know that any cryptographic protocol cannot guarantee you absolute security. The code or a system is secured within its threat model, right? If so, you have to know the threat model that this cryptography protocol or primitive offers.
All right.
If you step outside the threat model, all of a sudden you are in the insecure zone.
Okay. So, I mean, tell me honestly, when you said you worked as a professional in the payment card industry, did you ever write insecure crypto?
Insecure crypto, I think that the thing is, I might write some, but the thing is, I always look for, so when I started writing code, say for example, for hashing things, for example, when you do payment transaction, you have to generate cryptogram. So I have one nature, when I learn something, I actually try to learn from the ground up.
That's very responsible of you.
Yeah, so what I did, I even had to learn asymmetric crypto, how RSA works and all those stuff. And I learned about Bleichen-Bacher, padding oracle attacks and all those stuff, like logjam and all those stuff. And then I started writing code for myself.
I think not everybody has that much time to get their crypto.
As I can tell, most of the time we also had to work on pressing deadlines. So it can be hard.
So it's kind of a similar story for me. I got into regular expressions because I spent a couple years at IBM before coming to grad school. And I was a software tester at IBM. And one of my jobs was to confirm that the command line interface for our product worked properly.
I see.
And to check if a command line interface is working properly, one good thing to do is confirm that it's spitting out the right output. Well, guess what? Regular expressions are a great way to check that the output is what it's supposed to be.
I see.
So I probably wrote a couple hundred, maybe 1,000 regular expressions, which is why I love them, right? But I saw all these issues that I was having with regexes, even though I worked with them every day for years. And I saw issues that my coworkers had when they were looking at my regexes, and they were like, "We can't read this, and there's something wrong here, and we don't understand what it is." Right? It's just
Did you have any regex expert in
I was the regex. I mean, I read the whole Perl book, that camel thing. I read all 2,000 pages of it. I read Friedel's book on. I really wanted to get them right.
I heard stories like most of the companies and most of the team have their own regex expert. And other developers go to that person.
Well, I mean, it's funny you say that. We actually, when we were talking to all these developers, they said that. They said, when we have regex questions, there's this one person on our team, and we just call them over and say, please tell us what is wrong with this mysterious, syntactic nightmare. There's something wrong. We don't know what it is. You're the expert. Fix it. So we called them in that paper regex wizards. Right, because they were the only person in a team of 30.
How did they look like?
Oh, we didn't ask what they looked like. Probably a big pointy hat, though. Wizards, right? Magic wand, etc.
I can imagine.
Yeah. So you said that as a professional developer, you never made any crypto errors.
I didn't say that.
Okay.
I didn't say that. I didn't make any, but not consciously.
Yeah. But in your research, you have been looking at crypto errors.
Yeah.
So can you give kind of an example of a common error that you've encountered?
Yeah, that's I actually have several examples like that we actually see in the wild. So one common thing we saw that most of the people, what they do, say for example, you want to transfer data from mobile application to your server, but what you want is your data to be encrypted so that anyone in the network cannot see it. So what you can do is you do encryption, right?
Right. So I'm going to Google, right? I'll be your dumb developer because I don't know how crypto works. So I'm going to Google, I need to transfer data from a mobile app to...
So what people do is generally you will use, for example, symmetric key encryption. But the thing is, if your cryptographic key is hard-coded in the app, then all of a sudden, if anyone look into the app code or app binary, because you have to deliver or upload it to the Google Play, if anyone just scan your code or look into the source code or app binary, they will discover that key. So and within that moment, your whole crypto operation or your security is broken.
So you said that the problem is usually some disconnect between what the crypto was designed for and what assumptions it's making and how it's being deployed.
Exactly. So the thing is, when you step outside the threat model, you are insecure. So for asymmetric crypto, the threat model is you cannot tell what the key is.
Okay, but if I encoded that key into my software and then shipped that software to anybody in the Google Play Store, they can just kind of use off-the-shelf stuff and find the key.
So one thing is that. Another thing what we saw is the certificate validation, skipping certificate validation. So for example, so you want, so you have a web application.
Oh, I actually did this once, I think. So I have a website and it uses HTTPS and I kept getting errors. And I think I disabled certificate checking. I was Googling in Node. It was a Node.js app.
I see.
I don't really know what I did and what the implications are. Maybe you can tell me.
Yeah. So the thing is, when you disable the certificate validation or even hostname checking,
it was like an environment variable I set. It was like ignore all certificate checks.
So the thing is, whenever whenever you do things like that, there is no point of using HTTPS.
Well, I wanted to be able to visit the website with HTTPS colon. Because I was getting a warning from the security staff about that.
Exactly. You just disable the one.
Well, yeah. I mean, so it's not secure.
Yeah.
Okay. Can you tell me, like, I don't really know what happens when I disable the certificate checking. I know my website works and I can visit it on my phone. But
the thing is, so one thing is when you disable the certificate validity checking, anyone man in the middle can actually present their own certificate and emit it as Jamie Davis.
Okay.
And then what will happen is your server will, because you disable the certificate validation.
Yep, I did that.
Yeah, so the server will not even check whether this is real Jamie or not.
So does this affect me as the owner of the website?
No, the users who is connecting to your server are being affected.
So a client goes to connect to HTTPS colon my thing.
Yeah,
and because I've disabled the certificate checks.
Yeah, it can hurt your reputation.
That's not good.
If anyone just spook the content that you want to show and they just inject their own.
Okay, so anybody can pretend to be my website.
Yeah.
All right, that's not good. I should fix that.
Yeah.
Maybe we should talk after.
Yeah.
Okay. So that's two examples. I have the impression you talked about a lot more in your work.
Yeah, so there are some other cases. Those are not straightforward as these are, but there are other cases like some of the times when you for integrity checking, sometimes we use hashes, right? Cryptographic hash functions.
Sure.
The funny thing about cryptography is when the computing power gets better, some of those cryptographic primitives get insecure with time. So, say for example, if you used MD5 10 years back, it might be okay. But today, if you use MD5 or SHA-1, it's not okay.
Yeah, I guess those things were proposed like in the 70s. I feel like it's the
Exactly.
history of hash functions.
Exactly. So we saw lots of code base that still uses even MD4.
I've never even heard of that.
Yeah, there are things like that, and also not to mention MD5 and SHA-1, all kind of stuff. And also there are insecure symmetric crypto primitives, like NIST discourages to use blowfish, DES, this kind of cryptographic primitive, but we see lots of them out there. And even for asymmetric crypto, if you use, say for example, RSA 1024 bits or even 512 bits, you are insecure as hell.
So it sounds like you've got a big list of all the ways you can screw up crypto.
Yeah, so
is it like an exhaustive list or just sort of a top 20 type thing?
Yeah, the thing is, there are always new vulnerabilities, right? Yeah. So it's really crazy to come up with an exhaustive list. So what we did is we took some representative sample that we see in the wild, and we compiled a list of, I think, 16 type of misuses, cryptographic misuses, and we went from there.
So having this list, do I just sort of open up my code base and look at all the crypto calls and then compare it to your list? That sounds sort of labor intensive.
Yeah, so what we did is we built an automated tool that can detect all these 16 type of cryptographic misuse automatically. So when you are developing code, you can at the same time use our tool to check what sort of cryptographic misuse you have in your code.
Okay.
So that, I think that can be a useful tool for the developing community, and we also open source that tool.
I mean, we all know about research code.
Yeah.
Like it's sort of a hot burning mess. And like, does it work?
Yeah, it works.
Okay.
I can guarantee it works. If it doesn't work, you just can create a pull request.
Well, of course, and make a pull request.
Yeah,
sure.
I guarantee that I will fix it.
Yeah. So when you say you know it works, how do you know it works?
Because we extensively tested it. We ran our tool on 46 open source Apache projects.
Okay. Apache, the folks behind Spark and Hadoop. And
yeah,
so on, right?
yeah. So we ran our code on Apache Hadoop, Apache Spark, and Apache Obvious, and some Apache Ranger, Ambry, all sort of.
It's a huge community.
Yeah, it's a huge community.
Did they have any? It's sort of the burning question. Did they have any crypto?
Yeah, I'll come back
later.
Right. And we also ran our tool on, I think, more than 6,000 Android apps.
Oh wow, you were busy.
Yeah.
Okay.
So and we also manually checked the output of our tool, like how it's performing.
Yeah.
And I think the accuracy is over 98%.
Okay.
So we are really proud of the tool.
Can you give me like some sense of how the tool works under the hood, right? Somehow I'm taking your tool and pointing it at my code base, and it's figuring out that I've hard-coded keys or that my cipher's doesn't have enough bits or so on. What's sort of the technology underneath that?
Oh, so the thing is, we used data flow analysis. Like we know that the kind of cryptographic APIs you used, or for all these cryptographic vulnerabilities, we know the cryptographic APIs.
So is there like a set of crypto APIs you're targeting?
Yeah, so for Java, fortunately for Java and Android, these cryptographic APIs are standard.
Okay.
It comes with the standard.
So anybody with crypto in their code is going to be calling
these kind
like
of
a Spring security or something?
It's actually Java cryptographic extension, JCE.
Okay.
Yeah, APIs from there. And also there are some SLTLS APIs.
Okay.
So people will use those.
So you can kind of parse a code base and then find the function calls to these.
Not actually parse. Yeah, we look for these APIs, and then we run static analysis, like data flow analysis, to see the function points that we are targeting, how these function points are being influenced from the code, or even we also targeted like how things might go when anyone passes some argument from configuration files and things like that.
So if I've just got like this in your Android app, you talked about a symmetric key problem where they've just kind of hard-coded the key.
Yeah.
Right. If there's a function call where the first argument is the key and it's just
exactly.
like a string that's like, this is my secret key.
Yeah.
That seems like it's really easy to find.
Yeah.
Can you, when it's declared in a variable somewhere else or being
exactly.
passed in from a config
yeah.
file?
So the thing is, most of the time we see that it's buried under 5 or 6 function calls.
Hard to find.
Yeah, hard to find. And some of the times, if you do straightforward parsing or things like that, you might end up with lots of false positives.
Okay.
So that's the main challenging part of doing or building static analysis tools. So for example, when we created just vanilla program analysis tool, around 70% of the alerts were false positives.
Okay, that's not really a useful thing.
Exactly. So
okay.
That's why straightforward parsing or anything like that, even straightforward data flow analysis will not do a good job.
Okay. So you invented some new techniques.
Exactly.
Okay. Yeah. But the upshot of all this is that I can plug in your tool and it'll find real bugs.
Yeah.
Okay. Can you tell me about a couple of them?
Yeah. So in Apache Spark, we found things like, Apache Spark had some code.
This is Spark, like the data analysis tool. Okay.
Yeah.
Everybody's using it.
Yeah.
There's like a million blog posts on how to get started.
Yeah.
Okay.
So they also have some sort of web-based apps that you can, within your network, you might want to use that to use some of the services.
Okay.
And we saw that in that part, they also disable some of the certificate validation.
Well, they throw exceptions, right? It's hard to get that.
Yeah. Yeah. So after, when he communicated with them, they actually told that, yeah, we are on the way to fix them.
Okay.
We are trying to fix them.
So this thing that seems like sort of a naive, of course you shouldn't disable the certificates. I mean, I admit that I did that myself, but not like in a serious project. It was like a toy thing I put together. But even like Apache Spark, this wildly famous.
Yeah, I think part of the reason why they did this or supported this feature, this wasn't, I think, enabled by default, but if anyone wants, they can enable it.
Sure, IT staff often says we need you to be using HTTPS.
Yeah. So for most of the Apache project, we see that even if they're secure by default, they offer this insecure code. So that whenever you install those codes in your own machine, if you face, for example, you cannot properly set up HTTPS, you can disable things like that. So they offer those kind of insecure codes at your disposal. You can enable those features anytime
they'll give you
want.
The loaded gun and you can shoot yourself in the foot with it. Perfect. Excellent.
Exactly. So when we communicated these type of problems with Apache, so they actually defended themselves by this way. If a user enables these insecure codes, they're actually shooting their
but if you don't tell us they're insecure, that's hardly an excuse, right?
Yeah.
Huh, that's wild.
Yeah.
So we saw kind of similar things with regular expressions. The issues were, I think there's sort of philosophically a lot of overlap.
Yeah.
Cryptographic primitives and regular expressions are both kind of these black box things that you view as mystical and you Google on Stack Overflow and hope for the best. Oh, you said, before we go into regexes, you said that you found issues in real Java projects using your tool.
Yeah.
And you also kind of implied that on Stack Overflow, maybe you would be copy pasting code that would be not so good.
Yeah.
Is that the case? Like if I Google for how do I do certificate stuff and go look at those code snippets, are the snippets problematic?
Yeah. So so in Stack Overflow, when you look for answer, you will see lots of insecure code snippets. So generally, what our instincts are like, we see the upvotes. If we so if we see lots of upvotes in one question, we don't even think about the security and anything else. What we do is we just copy the code snippet and paste it in our ID and just click the run button whether it works or not.
Yeah, see if the things turn green.
Exactly. So that's the problem. My recommendations are like, just don't copy codes blindly. Also look for the problems you want to solve, whether they're solving those problems or they're bringing new problems.
Okay. So has anybody actually gone and looked at all those crypto snippets on Stack Overflow? Like, do we have some sense of,
Yeah, I
10%
think
of the time you're in trouble, or 95% of them are gruesome?
So in our group, we actually studied that I think around 2017 summer.
Okay.
And we actually saw that lots of those. I think most of the popular snippets are actually insecure. Yeah.
In some way or another.
Yeah, in some way. They are functional.
They're functional, yeah. Okay. Well, what a mess. What a mess.
So in my pastime, I also answer questions in Stack Overflow.
Do you?
Yeah. So whenever I see any insecure codes or things like that, I at least comment there with and I also sometimes try to edit the answer with a disclaimer that this might be insecure.
That's funny.
And also comment underneath the answer whether.
Yeah.
And what kind of insecurity.
Warning, I know a lot about this, so this is a terrible idea.
Sometimes this can also backfire you. For example, we saw things like, if anyone with low reputation in Stack Overflow try to comment this kind of things, some of the committee members might also react badly.
Oh.
Yeah. But fortunately, I also had enough reputation.
Oh, I see. So you kind of, inside the Stack Overflow moderation system, you need to have enough reputation, however that's acquired, so that people will take your opinion truthfully.
Seriously.
That's interesting, because like you're getting a PhD in security, you'd think they would just listen to you.
Yeah.
But you actually need to sort of earn credit inside the community before they'll.
And this is also a good thing, right? It takes years to build the reputation.
And I guess like if a thing's got 2,000 upvotes, I mean, it seems like a lot of people enjoyed it. So it should take a lot of reputation in order to.
The thing is, if you are reputed in, say, for example, Java code, how you can write or maintainable code, you got most of these reputation.
That's
from
true.
that it's really hard to tell whether your advices on how to use crypto is a good one.
Yeah, that's fair. Maybe my advice is just how to get crypto to stop throwing exceptions.
Yeah.
Right. So the reputation on Stack Overflow isn't tied to a particular skill set.
Exactly.
It's just
so that's where the problems come from.
That's interesting. So we see similar things with regular expressions.
Yeah.
It's probably not surprising. It's a crazy black box. Of course, there's weird stuff that can go wrong.
Yeah.
And I said that we talked to about 300 software engineers in my research. And like I said, they said regexes are hard. And when in doubt, they'll tend to copy paste stuff.
I see.
And in fact, we have this great quote from one of the participants. They said, if it's a common regex, I'll just Google and try to reuse it off Stack Overflow. And they even say that when they're reusing a regex, they'll skip validation sometimes. They'll say, well, if I'm using a regex from Stack Overflow with 500,000 upvotes, who am I to say it's bad? So I'll just copy and paste it into my code. Which is, exactly like crypto. It's the same thing. There are all these sort of hidden gotchas with regular expressions. And if you aren't an expert, then it'll kind of work, and you'll maybe even write a test case and it'll work fine. But there's sort of problems.
I have a question.
Yeah, go ahead.
So if I have a regex that's written for Java, will that work for Ruby, for example?
Well, that's sort of the fun bit, right? When you Google regular expression for XYZ, whatever it is, I need to parse a credit card number, right? So people use regexes. We've done other studies where we're trying to figure out what they're for.
I see.
And they're very commonly applied for form validation, right? On the client side, you go to type in a phone number and you want to give a fake phone number. So you're like, I don't know, 1, 2, 3, 4, 5. And it'll often say this is an invalid phone number. Or you type in a credit card number and you check the box that says it's a Visa, but you make a typo. And there's something that says this is not a valid phone number. This is not a valid credit card number. This isn't a valid email.
I see.
Often that thing is a regular expression.
Yeah.
And so they use them on the client side, and they're like, let me check the form's right. And then on the server side, they'll copy and paste the regex to the server side and reapply the check, because you can always bypass client side stuff if you're malicious. So you want to double check on at both ends. And often the server side code base is in a different language, right? Client side is always JavaScript, but server side is often Java. Sometimes it's Ruby. Sometimes occasionally it's Python. If you're into Node.js, it might be a JavaScript. So then it's the same thing. But even when you're changing JavaScript from, say, Chrome to Node, it's a different regex engine under the hood, right? The Chrome, Chrome's a bad example. Firefox has a different regex engine, right? Chrome and Node both use the V8 JavaScript engine. So the regexes are going to be the same. So you have this sort of idea that regexes are this universal language. And you want to copy and paste your regexes from your client-side JavaScript code to your server-side Java code or your server-side Ruby on Rails machinery. And you want to Google, hey, I need a regex for phone numbers. Hey, there's a hit. I don't really care what language it's for, because it's going to work in my programming language the same way. So we all have this kind of conception, and I'll actually be so bold as to call it a misconception, that regular expressions will work the same across programming languages. So
I don't remember I ever validated in the client side.
Well, it turns out that you should have done that.
Now I realize.
So if you go look at all the documentation for the different programming languages, every language has a regex library built into it. There's one in PHP, JavaScript, Perl, Ruby, Python, C#, Go, Rust. Everybody's got a regex engine. And they all have regex engines because they're so darn useful, right? Developers need to manipulate strings, and regexes are sort of the power tool for that purpose. But if you go look at the documentation for the regexes in the different programming languages, and you spend a long time doing this, right? At the surface level, it all looks about the same. You put, ABC next to each other, you get a star, you can have a plus, you can group stuff with parentheses. So at a surface level, the syntax is very similar. But if you keep reading, and I'll tell you that you have to read for a while because I've spent hours reading this documentation. Right?
It can be pretty boring.
But if it's fascinating in a boring way, but fascinating, right? If you keep reading the docs, you'll eventually find that there are some weird inconsistencies. And these inconsistencies are of two forms. The first form is where, maybe three forms. Sometimes a programming language does not support the same features as another programming language. Right. So in JavaScript, you've got the ability to make a back reference, which is this sort of fancy extended feature. You don't have that power in Rust or Go. So if you're looking for a back reference in Rust or Go, you just won't find it in the docs. Now, it's not documented that it's not there, so you have to kind of know what you're looking for. But if you copy and paste a regex off a Stack Overflow that has a back reference into Rust code or Go code, it won't work. You'll get a compilation error. Hold that thought, though, because in Rust, you won't get a compilation error. In Rust, you'll get really weird behavior instead.
Wow.
It's fun. So there's this one thing where the feature's not supported. Right. Then there's this other class of issues where the feature is supported, but it means a different thing. Right. So in Ruby,
that can be devastating.
Oh, it can be also very hard to debug, because if you're used to like Perl regexes and you're writing a regex in Ruby, this notation meant one thing in Perl and it means a different thing in Ruby. So good luck figuring that out. I actually saw this great example recently of a regex in JavaScript that used a \h, which in, I think, Ruby means a horizontal white space. And in JavaScript means the literal character H.
I see.
So there's this regex in JavaScript that does not match horizontal white space, it matches the character H. And it had been in the code base for years because it was sort of in an untested part of the regex. And I asked the developer, I said, this is not right. And they said, oh, I don't really know how that got there. I guess I was thinking about Ruby that day. Right. It's just very hard to keep all these variations straight in your head. So that's another example of sort of a semantic inconsistency where there's this notation, but it doesn't mean quite the same thing that we're used to. And sometimes it's obvious, right? Okay, it matches an H versus horizontal white space. But sometimes it's actually sort of bizarre. There are these things you can sort of put parentheses inside each other, and you can put stars and pluses in there too if you want to. Things can get a little hairy. And you can actually create very short, minimal examples of a regex like nested A plus with a plus on the outside, where it will actually behave slightly differently in two different programming languages. And it's not documented anywhere, right? They both say this is what a plus does and this is what a star does. But when you start talking about the interactions of these features, the documentation quickly becomes very silent, right? There's just crickets. It's like, we hope that no one ever tries this, and we're not willing to document the actual behavior. There have been some efforts at regex standardization, right? So there's a couple different POSIX specs, and there's the Perl compatible regex spec, PCRE. No one has really sort of gone gung-ho in adopting these. Everybody says, we kind of follow the POSIX PCRE spec. We're not willing to like sign that in blood or anything. But in general, it's going to look about the same. And so when things look about the same, developers have this impression that they'll behave the same. And that's not really the case. So we actually ran an experiment, right? So in addition to reading documentation for many hours, which I assure you was very fun, we also downloaded about 200,000 projects off of GitHub in 8 different programming languages.
Wow.
And we extracted all the regexes from them, which gave us
a large corpus.
Yeah, we have about 500,000. So if you happen to need a regex, I have 500,000 of them. So we pulled out these regexes from all these different projects, and then we said, well, now we have a giant collection of regexes. Do they behave the same? So we took these input generators from a couple different places. Microsoft has an input generator for regexes. There's a few different academic teams who've got input generators. But basically, it's, given this regex pattern, give me some strings that are interesting, and some of them will match the pattern, and some of them will not match the pattern in different ways. So I built, about 2,000 inputs for each of these 500,000 regexes. We're talking about, a lot of computational power here. I used a supercomputer. It took a couple days, but you generate, a lot of these things on your 10 nodes of.
For my research, I don't need supercomputer.
Yeah, I used a couple terabytes of RAM, I think. Anyway, you generate all these things, and then you're like, well, I have this input for a pattern, right, a regex, and I got the regex out of JavaScript. Now let's see if I copy and paste this regex from JavaScript into Python. Exact same regex, exact same input. Let's check if the behavior is the same. And it turns out that about 10% of the time, the behavior will be different, right?
Wow.
So we have 500,000 regexes. On 50,000 of them, there is some pair of languages where there's some input that they'll behave differently on, which is like bizarre to me that it's that high of a proportion. We actually kind of broke it down into sort of what's the root cause here. And some of these things are documented, right? So it's like this \h of white space or literal H. You can find that in the docs if you look hard enough and you know what you're looking for. Others of these things are not documented, right? So there's literally no way to find this out other than some sort of ancestral tradition about how regexes work. Or trying this experiment yourself at home, which I already did for you.
Do you have any recommendations of how you can write good regexes, or what you should look for, or what you should avoid when you are writing regex?
I think when in doubt, open up the regex manual for your programming language and use it. So we talked to 300 software engineers, and maybe 20% of them said that when they write a regex, they actually pull up the manual and confirm it's working properly.
How many pages of manual we are talking about?
Well, it depends on the programming language. The POSIX spec runs to like 100 pages because it's a POSIX spec. So of course, it's just a ridiculous standard. But the Python documentation, for example, is not too bad. It's, maybe 10 pages or so. But you can usually, Control F to find the feature you're looking for. But there's really no substitute for double checking that every piece of this regex does what you think it does. And there are some online tools for regexes that have like little cheat sheets built in explaining what the syntax does, but they're not always accurate because it assumes something about what programming language you're in. So you just want to be very careful about.
How many percentage of the developer read this manual, you think?
Well, so I said about 20% actually reference the manual in the day-to-day. The other 80% hope for the best, right? They said that. They said, we just kind of hope this works, and we write test cases. So there's this fun thing about test cases and regexes. There was a paper last year from a group at NC State, and they ran a bunch of Java programs. So they downloaded a couple thousand Java projects and ran their test suites, and they pulled out all the regexes and all the inputs for those regexes. And you can kind of think of the input for the regex as like a test case. And you can think of the regex as like a little program. And if you think about the regex as a little program, you then want to say, well, what about the code coverage for my tiny program here? And all these inputs from the test suite are basically test cases for the lines of code in your little regex.
Yeah.
And the folks at NC State said, the code coverage is terrible. So like the line coverage is fine in the product, right? You're getting input to that line and evaluating the regex. But the regex matches tons of different stuff.
Yeah.
And if you look at it as an automaton, only about 50% or less is actually getting covered by those test inputs.
Yeah, I think that also makes sense, right? It's really hard to generate all possible sort of, or in a constrained environment.
It is hard.
Yeah.
You should do it anyway.
Yeah.
All right. So when you copy and paste regexes off of Stack Overflow into your code base.
So for example, when I had to match email for regex, I always go to Stack Overflow and copy the one who has the highest number of outputs.
So what's a little tricky there is that when you're copying it into your code base,
Yeah.
if the language doesn't match the programming language, then it may not have quite the same behavior that you're expecting.
Yeah.
And this can lead to all sorts of exciting problems, all the way up to like SQL injection attacks, depending on exactly how different the behavior is in the destination programming language. But that's all about program correctness.
Yeah.
There's this whole other aspect of regular expressions that can be problematic, and that is their performance.
I see.
So we think of regular expressions as a fairly fast thing because we feed them strings and they feed back a match, and we're like, cool, a match, good enough for me. I'm going to spend 5 seconds handling this client request, and what's 10 milliseconds doing a regex match. But it turns out that in most programming languages, the average case performance for a regex is fast. It's linear in the input you give it.
Yeah.
But the worst case performance for a regex can be as bad as exponential in the length of the input. So what does that mean? It means that there's some regexes out there. You give them 100 characters and they'll take 100 years to finish the evaluation. Right? Exponential is a really bad word. There's a whole bunch of other ones that are polynomial. So it's also a bad word. It means I give it 10,000 characters and it'll take a couple years to solve that. I mean, it's a lot better than 1,000,000 years. But if I can get 10,000 malicious characters through your web form to this regex, now your server is going to spend years operating on behalf of this one malicious client. It can really bite you. We actually went out and measured. Of course, right? We went out and collected a bunch of regexes and checked what they did. And so first, most programming languages have this worst case behavior problem. Right? So in everything but Rust and Go, you can get at least polynomial time. In everything but Rust, Go, and PHP, you can get exponential time. So we looked at 8 programming languages, 5 out of 8 exponential worst case behavior, very bad. 1 out of 8 polynomial worst case behavior, and 2 Rust and Go are pretty good. Those devs have been very careful about their regex engine behavior. And you might think that no one would really write a regex like this in practice, but we checked that too. It turns out that about 10% of the regexes that people write exhibit superlinear behavior, right? They're either polynomial or worse, which is a scary number because these regexes appear in some interesting places. So as part of that research, we found superlinear regexes that could be denial of service vulnerabilities, right? If you're running a web server and someone gives you a bad input and you take a year to process it, you're burning a lot of compute power handling an attack, right? That's a DOS vector.
How do you think you can tackle this regular expression denial of service attack? Should these defenses come from the regex engines, or should developers fix or know what type of regex they're doing?
It's a great question. So you have a couple different options, and we've actually seen all of these happen, right? So in this empirical project, we found a bunch of vulnerable regexes, and we emailed the developers. So we emailed about 200 devs and said, hey, this regex could go haywire, you might want to fix it. And we looked at how they fixed it. So some of them say, well, it's polynomial, so I'll just make sure the input's not too long. And that'll be totally fine, right? It's still going to be polynomial, but it's bounded at a millisecond, so no biggie. Other developers will revise the regex. So they'll take the regex and they'll try to rewrite it so that it'll still match more or less the same string set, but it won't have this sort of super linear behavior afterwards. They're not always perfect at that. This is a tricky problem, and people make mistakes. We actually found some regexes that had previously been repaired that were still vulnerable, just in a different way.
I see.
And then another option at the application level, you can bring in a different regex engine.
Yeah.
So Google has this regex engine called RE2, and they've got bindings in all the different programming languages you typically use. So you can actually add that as a dependency to your project and feed your regexes to that. Now this has its own problems, right? If you have these portability issues between regex engines, you're going to need to be very careful about confirming that the regex behaves exactly the same way as it used to.
Yeah.
And if your test suite is inadequate, good luck with that, right? You'll need to beef up your test suite before you take that route. Another option which is available is to change the regex engine itself. And that's actually where I'm kind of going in my future research is, now that we know that this problem is out there and affects lots of applications, can we sort of systematically fix it so we just never have to worry about this again? And I think we can. Rust and Go have tried one approach, and I'm proposing a different approach that I think will be appropriate for lots of different programming languages. So Sam, we can keep talking, but if there are questions out there, we'd be happy to answer specific thoughts from folks.
There are no specific questions at the moment. Seems everyone's captivated by the great conversation between the two of you. I've definitely enjoyed it. So we've got a few minutes to carry on. I mean, do another shout out to anyone listening who does have a question. Please feel free to pop it in the Slack. But yeah, at the moment, no questions from our end.
So Sazzadur, I have a question for you then.
Okay.
What is it like for you to be a security researcher? Right, you're sort of deep in the muck of how these cryptographic protocols work. And over in the real world, there are lots of folks who don't really know how these things work and they're just hoping for the best. And it seems like there may be sort of a disconnect between the research community and the practice community.
Yeah.
Sort of what kind of a burden do you carry as a researcher, and how do you try to bridge that gap?
I think it's a roller coaster ride. And what we see is there are lots of the things as a researcher we care about, but we sometimes get really hard time to convey our message to the developer.
Okay.
So that part sometimes can be frustrating, but we eventually, after a few years, you will learn how you can deal with that. So currently, the motto of my research is to make whatever. So I think the liability is from both ends, from the research community and also from the developer community. From the research community, what we do is we work on an interesting project and we publish a paper, and after sometimes we really forget that we actually conducted the study or did the research for the betterment of the developer.
Okay, you just kind of get stuck. It's an exciting problem and you forget why you're doing it.
And after some time, what we do is we just forget about that. The main problem is if you don't pursue your the problem or pursue the problem in depth, if you don't spend some effort to deliver that to the developer, it's really hard for the developer to adopt what you are proposing or what you want them to use.
Yeah, I've had kind of a similar experience. I did a little bit of work on Node.js when I was starting out as a researcher, and I felt very much like an outsider in that community, right? It's this huge active developer community, and I'm just a researcher, kind of make myself heard with suggestions.
I also felt similar thing when I started communicating with Apache developers.
I'm not worthy, you know.
It's like initially it was pretty disheartening because from my point of view, I was a novice, just a PhD student who discovered some issues and really excited to report them. So, but from their end, it's like I wasn't that much welcome. So initially that might be disheartening, but eventually you will learn that that's the way it works.
Yeah,
because nobody is on the other one's shoe.
I had a similar experience. So I found regex vulnerabilities in the core libraries of Python and Node. And I got out my computer that day with great trepidation and typed, security@python.org.
Yeah.
Hello, I think I found a security. And you're like, I can't believe there's a security vulnerability here. So, you check the email 10 times and you ask someone else, do I look stupid? Does this make sense? And you finally send it. And I was actually, maybe the Apache devs pushed back on you a little bit, but the Python and Node core maintainers were really generous. And they said, either.
Oh, most of the Apache project was really generous. And I really learned quite a lot by interacting with them. It's really, it was an honor.
I think it's great to see researchers invest enough in the community that they're trying to solve problems for, that they can really sort of understand all the pros and cons of the approaches that they're taking. Right? You can naively say, oh, well, all your regexes are problematic and you should throw them away. But from a software engineering perspective, we're not going to do that. But it takes a good investment from researchers to really understand the context that the problems that they're tackling live in, so that they can really give appropriate advice and kind of see the whole picture.
And it's also important from the researcher perspective to make the community understand the problem.
If they don't know, then
if they don't know, they don't really care. So my motto is to, whatever I do, I plan to democratize the research. So that other researchers can work on it. And I also plan to most of the solutions more practical, so that developers can also directly use my research outcome.
So I have a question for you.
Go ahead, Sam.
We're a developer-focused community, so hopefully we have quite a few developers that'll be watching this over the time. If there was like one little thing they could do that you think would help sort of bridge this gap between the researcher and the developer and make it a nice, more sort of inclusive space where you can reach out and ask those questions or understand, the environments they're working on. Is that one little thing that you'd be like, please, can we do this or not this? If you could speak to a sea of developers right now.
And I think if you ask for one advice, I would say just keep your eyes open. Whenever you think you are doing something that might impact the security, keep your eyes open whenever you are doing that.
Constant vigilance.
Constant vigilance. That's the only way to go.
Keep your eye on the prize. Perfect. Well, I actually think that we actually have a question. Perfect timing because it's about to wrap up. But Rick would you recommend any regex checkers on the web for those not using a regex detector module?
Okay. So I am actually the maintainer of the Safe Regex module on NPM, which is not perfect, but I'm improving it. That's the link to that. And I've put a more sophisticated set of tools into this other project called Regex Detector. And essentially what that is sort of a nice one-stop shop to wrap around a bunch of different academic tools, right? There are these mathematicians who've made fancy tools to analyze your regex mathematically. And I've taken their software and put a nice user interface on top of it. And the tools all have different pros and cons. So I kind of query all of them and then say, all right, this is what the group has decided about it. And there's also a dynamic aspect to that. So once they reach an opinion, you can then validate that it's correct in your programming language. That Regex Detector suite will support 8 programming language checks. I would welcome more if anyone wants more programming languages. But those both work. Safe Regex is okay. It'll get better in a couple months. Regex Detector is the state of the art pretty much in terms of checking regexes.
Awesome. Thank you so much. Well, unfortunately, that's all we have time for today. But I'm sure everyone who's listening enjoyed it as much as I did. So a huge thank you again. Hopefully, it is the first time we're having you on the show, but hopefully not the last time. So I think there's definitely a lot we can do together. So again, thank you so much. For anyone listening, our next session will be in 2 weeks' time, and we're going to be talking about building secure React applications with Ron and Jim from Manicode. So please join us for that. Yep, that's all we have time for. Again, if you enjoyed it, please share. Everything will be on the website in a few minutes. I just have to get it there. And thank you again, and have a lovely morning, evening, lunchtime, wherever you are in the world. Goodbye.
Yeah, goodbye.
Bye,
Nice
everybody.
talking to you,
Nice
Sam.
to talk to you.